Lesson 3 of chapter 2, we're getting into subtracting rational numbers. So this is the same as when we would subtract integers. So to subtract rational numbers, follow the same rule as subtracting integers. We're going to do that KCC again. Reminder, let's fill this in. KCC stands for keep, change, change. Now, maybe you liked our other rule I introduced to you back then as well, which was add a line, change the sign. That applies here as well. So we're either using keep, change, change, or add a line, change the sign, however you prefer to remember it. That is the rule that we're doing, because again, keep, change, change is the same thing as add a line, change the sign. So we're going to do those rules, change it. Remember, it gets changed to addition, and then we use our SADS rules again. Okay, so multiple steps here. And now instead of adding and subtracting positive and negative whole numbers, we're adding and subtracting our positive and negative fractions and decimals. So again, we have to remember how to add and subtract fractions and decimals from our previous lesson. We're kind of compiling it all, bunch of steps, bunch of rules all into this lesson here. So we'll take our time, make sure you're filling in everything and writing everything as I go through it. So first of all, let's give an example of a pair of opposite rational numbers. Remember, opposite means we have one positive, one negative. So one will be a positive version of the number, and one will be a negative version of it. And all I want you to do is give me a pair of opposite rational numbers. So you can think of a pair on your own. I'll give you an example here, positive 1/2 and a negative 1/2. Right? All I'm looking for are opposite, either fractions or decimals. So make up your own or write down my example. There are countless, infinite, endless examples here that you could have and you could be correct. Okay, if you want to play it easy, play it safe, and do one that you know for sure is right, there's my example right there for you. All right, we're going to go through these examples together. We're going to take our time. We're going to write down each and every step because this is your notes. And we're going to do these 4 examples together. So first thing is first, looking at number 1. I notice there's subtraction, so I should be thinking of my subtraction rules. KCC, or add a line, change the sign. So I'm going to put KCC, and now let's actually do that. Keep negative 7/8. Change subtraction to addition. Right now that is a positive 1/4, so we're going to change it to a negative 1/4. Now that I'm at my second step, right, now that I have an addition problem, I'm now thinking of my SADS rules. So now look at these numbers. Do they have the same signs or do they have different signs? Hopefully you're saying to yourself they have the same signs. So if they have the same signs, what are we doing with those numbers? We're going to be adding them and keeping the same sign. Now, in order to add these fractions together, what do they have to have? Hopefully in your head you're thinking common denominators. So right now we have an 8 and a 4. I know I can change that 4 easily to an 8. So I'll keep this as negative 7/8. Now I want to change this 4 to an 8. What do I do to 4 to get to 8? Multiply it by 2. So now do the same thing to your numerator. What is 1 times 2? 2. Remember, this stays negative. Now we know they have the same signs, so we're adding them. Now we can add them because they have the same denominator. What is 7 plus 2? Remember, you add across your numerators. So 7 plus 2 is 9. Keep your denominator and keep your sign since it's the same. I don't want to leave my answer like this. Why do I not want to leave my answer like this? Yes, it's improper. So make it into a proper fraction or a mixed number. How many times can 8 go into 9? How many are left over? So 1 and 1/8 is our final answer. -1 and 1/8. All right, let's move on to number 2. I see subtraction between my two numbers, so let's do our K, C, C. Keep the first number exactly how it is. Keep the sign and everything. Change my subtraction to addition. Change this positive 15 and 3/10 to a negative 15 and 3/10. Now you should be asking yourself, our adding rules, do these have the same signs or do they have different signs? I see they're both negative, so they're the same. If they're the same, we're then going to add them. In order to add decimals, what do? We have to stack them. Line up your decimal. Now, if we're adding, does it matter which number goes on top? Nope. Just make sure you line up your decimal. 5 plus 3 is 8. Bring down your decimal. 2 plus 5 is 7, and 1 plus 1 is 2. Since both numbers were negative, my answer should be negative. Go ahead and place our final answer in the box. -27 and 8/10. Make sure you have your decimal in there. Hopefully, this is feeling good to you. If not, pause as you need to, take a break, write it all down. Try not to move too quickly. At the same time, I don't want this video to be super lengthy. I know it's hard to focus when a video is too long, but make sure you're writing everything down with me. All right, number 3, let's take a look. I see subtraction, so first thing I'm going to do is K, C, C. Do you have to rewrite it every single time? This is what some people ask me. No. Write in here if you want to change that to addition and change that to a negative, go for it. If it helps you to rewrite the whole thing, whichever works best for you, do. Okay, these are your notes. This is your way of doing it. Just don't get yourself confused. Now that we have an addition problem, I'm thinking of SADS again. And hopefully you're going to ask yourself, do these have the same signs or different? I see the same again, so we're going to add them and keep that same sign. So maybe you want to put that sign in your answer box. It's going to be negative. Now notice, I see a mixed number and an improper fraction. In order to add these, you need to make them the same, whichever it is that you prefer. I'm going to make that 6.5 into an improper fraction. 6 times 2 is 12. 12 plus 1 is 13. So I have 13 over 2. Remember, it's negative. Plus a -4 over 3. Now, in order to add these, they have to have a common denominator. So I'm going to make them have a common denominator. I'm going to make them have a 6, because I know 2 times 3 is 6. So if I change this to a 6, I multiplied by 3. That means I need to do that to the top. So 13 times 3 is 39. Keep it negative. Plus, now I need to do the same thing over here. Change this to a 6, but now I'm multiplying by 2. 4 times 2 is 8. Same signs, we're adding those numerators together across. So 39 times 8 gives us 47. Keep your denominator a 6. Keep your answer negative. But I wouldn't leave it like that. Why shouldn't I leave it like that? Because it's not in simplest form. So now simplify that. You would simplify it by making it a mixed number. So how many times can 6 go into 47? Think of your facts. It should be 7 times, because 6 times 7 is 42. So now how many is left over? 5 over, keep your denominator 6. There we go. That's it. Let's move on to number 4. Again, first thing you should do when you see subtraction is keep, change, change. Change that subtraction to addition. Change that negative to a positive. So now I have a negative and a positive number. Now when I'm thinking of SADs, guess what? They have different signs. So that means I'm going to subtract them. When I'm subtracting my decimals, not only do you line them up, but you put the larger one on top. I don't have a placeholder there, so I'm going to put a 0. And now we just subtract like we normally would. 11 minus 3 gives me 8. Bring down your decimal point. 7 minus 4 gives me 3. And now just check yourself. Should my answer be positive? Or should it be negative? Take a look. When we're deciding that, you take the sign of the larger number. So 8.15 is larger and it's negative, so that means my answer is going to be negative. Alrighty, let's do our last part of this lesson here. What happens if we're finding the distance between two numbers? So distance between two numbers on a number line. Notice it's a positive and a negative number. Whenever you have opposite types of numbers, you're finding the sum of their absolute value. That's how we're finding distance. How far away are they from each other? This is our absolute value signs. Remember that from our first chapter. We'll just plug in those numbers. 2 1/3. We're going to add that with the absolute value of a negative 2 2/3. We're finding how far apart are these numbers on a number line. Remember what absolute value does. It's how far away is it from 0. It makes everything positive. So 2 1/3 plus, this is going to change to a positive 2 2/3. Now we just add them together. You can keep them mixed if you like to add them as a mixed number, if you can do that, right? If you do that, you would just be adding your fractions together. They already have a common denominator. So 1 plus 2 is 3. Keep your denominator a 3. And then you would add your whole numbers. 2 and 2 is 4. However, be careful. What does 3 over 3 really equal? It's a whole, right? If you have all 3 pieces to your pie, you still have a full pizza pie. So then you would have to add those together. What's 4 plus 1? The distance between these two numbers is 5. Now maybe you're like, wait, what did you just do? So maybe you don't like to think of it and can't add, or don't like to add them as a mixed number, so you can make them improper. 3 times 2 is 6, plus 1 is 7. Plus, let's do this one, 2 times 3 is 6, plus 2 is 8. Just add across your numerators. 7 plus 8 is 15 over 3. But simplify. How many times can 15 go into 3? Or how many times can 3 go into 15? 5. So you still get 5 as your answer. The distance between these two numbers is 5 units away from each other. We're going to talk